Hello, first grade teachers. The purpose of this video is to provide an overview of the standards, intended pacing, and sample instructional strategies for Unit 2A. In this portion of the video, we are going to review the AKS and Indicators of Achievement, or IOAs, for Unit 2A. The AKS is the overarching knowledge and skills that students are expected to master. The IOAs are the learning objectives that allow students to demonstrate mastery of the AKS. Remember, some AKS and IOAs will appear multiple times throughout the year to build and deepen student understanding. In Chapter 2 of the video, we will look to see how the AKS and IOAs in this unit are paced in detail. Unit 2A has two AKS, AKS 2 and AKS 6. You began working with both of these AKS in Quarter 1. AKS 2 involves solving addition and subtraction problems within 20, explaining the relationship between addition and subtraction, and applying the properties of operations. In Quarter 1, this thinking was done to solve problems within 10. For Unit 2A, we will extend student understanding to solve problems within 20. The IOAs go into further detail about the expectations for the standard. In IOA 2A, students are solving problems involving addition and subtraction within 20 using a variety of strategies. Problems involve a variety of problem types that are relevant and meaningful to students' everyday lives. The Georgia DOE has provided a document that shows the different problem types that students are expected to know and master. You will see that the problem types begin with action problems. We have joining problems that involve an action happening and separating problems that will also involve an action happening. As we progress through the problem chart, we move to problems that have no action, part-whole problems, and compare problems. The further down the chart and the further to the right are problems that would be more difficult for students to solve. We need to make sure we are mindful when we are describing the minus sign as minus and not as take away. Take away represents an action. So we want to make sure we're being really mindful about how we are representing our equations and verbalizing those to our students. You will see this chart has been linked multiple times throughout the pacing guide, and the problem types will be shown on each day of instruction. As we continue to look at the IOAs for AKS 2, IOA 2B describes the work that students do during number talks. When we look at the pacing guide, you will see that this IOA is strategically developed by the implementation of intentional number talks that allow students to explore relationships between numbers and develop strategies for addition and subtraction. IOA 2C, students are required to recognize and use the inverse relationship between addition and subtraction to solve those authentic problems mentioned earlier. Finally, for IOA 2D, students will have the opportunity to develop fluency for addition and subtraction within 10. You can see that we will also be revisiting AKS 6 and IOA 6D. AKS 6 is our measurement and data standard, but we are only focusing on one specific piece at this time. Asking questions and answering them by gathering information, making observations, and using appropriate graphical displays. In Unit 2A, students will carry on with IOA 6D. They will have the opportunity to continue to learn how to collect, organize, represent, and interpret data to answer questions about their world. The data will have up to 3 categories. Students should be provided with opportunities to create and explore statistical investigative questions by collecting and analyzing data. Now, let's look at the pacing guide to see how the AKS and IOAs have been paced out over the course of Unit 2A. In the top portion of the pacing guide, we see the name of the unit, the big ideas for the unit, and the suggested pacing. Unit 2A will focus on numerical reasoning and measurement and data reasoning. The suggested pacing for this unit is about 5 weeks. In the next box, we see the first AKS and IOA that will appear in the unit. In Unit 2A, we will begin with AKS 6 and IOA 6D. The left column of the pacing guide will list the progression through concrete and representational, then abstract strategies. The bullets also indicate the learning objectives for the day, as well as suggested manipulatives. The right column of the pacing guide shows the instructional resources that align to the intended learning objectives for each day of instruction. Some days you will see instructional resources linked for the traditional numeracy lesson. Other days you may notice a task-based lesson, which is your full numeracy block for that day. For IOA 6D, we are starting with 2 days of task-based instruction. This IOA has already been introduced and will continue to be revisited throughout the year. As you dig into these lessons, you will notice that the focus of instruction has shifted to more of a student-driven approach, using the statistical reasoning framework to provide a richer, more meaningful experience with data. Students will engage in task-based learning lesson that has been paced over the course of 2 days. You can see the bullets on each day outline how students will organize the data from a statistical question, represent the data using a graphical display, and interpret the data. On the second day of instruction, students will ask a data collection question, collect, represent, analyze, and interpret data. To learn more about the differences between a statistical question and a data collection question, please see the Analyzing the Standard. During these 2 days, students will be exploring different ways to organize data into categories of their choosing, make decisions about how to represent the data, and then move into generating their own data collection question and gathering data to analyze and interpret. You'll see that both of these days are concrete and representational, as students will use either or move fluidly between both while working on these concepts. All right, you guys, next on the pacing guide, you're going to see that instruction is going to shift to AKS 2. We are recommending around 21 days of instruction for this AKS. You're going to notice that IOA 2A, B, C, and D have been clustered together in meaningful ways over the course of this unit. But if you're looking at like that very first day of instruction, you see that IOA 2A is listed first and it's also in bold. That's because that IOA is the main focus of your lesson and your student tasks that day. So that's why that's listed first. You're going to also notice that for your activating strategy, 2B, IOA 2B is listed right here with that. And that's because these activating strategies have been intentionally selected and paced. So they're going to build on each other. So it's really important that you guys are following those and doing those daily in the order that they're intended to be done. The other thing you're going to notice is that IOA 2D is being addressed within this fluency task. These are embedded as one of the student tasks that you can use. And that's how we're really kind of getting at IOA 2D, that fluency within 10. I also want you to take note of the top of the pacing guide right here. It says that take notice that the first days of instruction, we're going to be introducing a new problem type and strategy, but we're going to continue to revisit previous problem types and allow students to use a variety of advanced counting and part-whole strategies throughout the unit. So we're going to continue to introduce new problem types and new thinking strategies, but students have the flexibility to choose the strategies that make sense to them and that work best for them. So just making sure they're able to be flexible, and we're continuing to revisit problem types in our small groups as well. Okay, you guys, so as you are looking through this unit, you're going to see that the instructional strategies progress from concrete to representational, and then we're back to concrete again. So why are we doing that? Concrete strategies will reappear when a new problem type or thinking strategy is introduced. So we're starting off that first day with that joining action problem, the result unknown that was at the top of our chart. It's the easiest ones for students to do. We're going to do that concretely with counters, 10-frame snap cubes. We're going to organize our thinking in a part-whole organizer. Then we're going to do that same problem type, but we're going to move to that representational level. So we're going to make that connection between the manipulative that we used and drawings. We also may use a number line to represent our thinking. On the next day, we're back to concrete again. And that's because we're introducing another problem type. We're going to do that separating result unknown problem type using the removal strategy. So we're back to concrete, our counters and snap cubes again. And then again, we're going to follow that same thinking. We're going to progress to representational using our drawings. So you're going to see that is kind of how the unit is paced with problem types and strategies going back and forth. The other thing I want to remind you of is in Unit 1B, you began an addition and subtraction strategies anchor chart. The lessons in this portion of the pacing guide suggest that teachers continue to add strategies to the anchor chart during their instruction. So as you're introducing that removal strategy, you can add that to the anchor chart that you already started while you're teaching your mini lesson for students to reference. So we are going to continue to progress through, still seeing those intentional number talks for 2B, going back and forth between concrete and representational until we get down here. It's around the 12th day, but you are going to see this bullet over here. Now we have 2A and 2C. You're going to notice that 2C is also bold, and that's because 2C can be added because the problem type that we're using now will allow students to use the inverse relationship between addition and subtraction to solve. So we're going to kind of hit that a little bit later on, but that again is based on that problem type. So we're back to concrete again, using those snap cubes and continuing that work. So you guys are going to have lots of opportunity to work with students using different problem types allowing them to be flexible with their strategies, but you are going to introduce them to several different strategies and different problem types. So lots of days of instruction. Hopefully you guys will see that there are lessons on every single day. There are tasks on every single day. And everything is really teased out to align and hopefully meet the needs of your students. So we hope that you found this helpful. Hang out for Chapter 3 and see some instructional strategies that you might want to use. This portion of the video will highlight specific instructional strategies that will be utilized in this unit. Please refer to the Analyzing the Standards, or ATS, for guidance on additional instructional strategies for each IOA. Today, we will begin with our Start Unknown problem type, where there is a joining action taking place. Children were playing at the park. 7 more children joined them. Now there are 16 children at the park. How many children were at the park before? Okay, so before I really start doing any computation or trying to solve anything, I want to play a math movie in my head. So let's see, when I close my eyes, what am I picturing? All right, so I'm seeing that there are some kids at the park. And then I see that 7 more children joined them. So I got some kids at the park, and I know that 7 more are going to join them. And now there are total. So that means I started with some kids, 7 more joined them, and there are 16 children total at the park. And I want to know how many children were at the park before. So that means, like, how many children did we start with at the park? Well, that's what we're looking for. How many children were at the park before? So now I kind of have a picture of what's going on. I have my math movie in my head, and I want to think about how can I solve this problem and how can I organize my math movie. So I know one thing I can do is organize my thinking in a part-whole diagram. So I'm going to draw my part-whole. I know that in my part-whole diagram that I can see the parts and the total and how they're related to each other. So let me think about what I know. I know that we started with some kids. Then we had some kids join. And then I had a total number of kids. So I started with some kids joined, and then the total number of kids is how many I had all together. So when I'm thinking about this, going back to my math movie, some children were in the park. I don't know how many children started in the park. But I do know that 7 children joined them in the park, and that when all the children were together, there was a total of 16 children. So this part-whole diagram allows me to see the relationship between these 2 parts and their whole. Well, if I think about what's happening in my story, I know that I started with a question mark. I don't know how many children started in the park. Then I added 7 more children. 7 more children joined them. And finally, when I finished, there was a total of 16 children in the park. This equation matches what happened in my story. But I need to know how to solve this problem and to find that missing number. Well, I know that part whole helps me see the 2 parts put together would equal the total, or I can take that total and subtract a part and that would give me the other part. So if I take my total of 16 kids and I subtract the part 7, then I will be able to figure out how many children were at the park to begin with. So I have my situation set up. Now I want to use a tool to help me solve. Today I'm going to be using my part-whole diagram and my color tiles. So you can see that I've already placed my 16 total children in the hole. And I know that I'm going to think about these children and how they're going to be split into my parts. So I know that I had 7 children join. So out of these 16 children, 7 children are the ones that joined. So I'm going to move 7 kids up. 1, 2, 3, 4, 5, 6, 7. These are the kids that joined. Out of the 16 kids, that means the rest of those kids were the ones that were already in the park to start with before. So how many kids were in the park before? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 kids were in the park before. So in my part whole, that means that 9 kids started in the park. So we could put a 9 in that box. Or 16 minus 7 is going to be 9. 16 minus 7 equals 9. So let's consider how we could solve this problem in another way without concrete manipulatives. We could also draw a picture. So if I'm thinking about how to draw a picture related to the thinking I've already done, I know that I would need to draw all of my students. So I am going to draw all 16 students. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. These are my 16 total students. Out of the 16 total students, I know that 7 would be the number that joined. So I am going to show the 7 kids that joined in a group. 1, 2, 3, 4, 5, 6, 7. So these 7 are the ones that joined the other students at the park. So now I can see that 16, and if I take out the ones that joined, I'm left with the students that started in the park. So how many students started in the park? We have 1, 2, 3, 4, 5, 6, 7, 8, 9. These are the students that started in the park. Again, I was able to show that starting with that total of 16, removing that part of 7, left me with the 9 students that were initially in the park or started in the park before. Once students are ready, you can also show them how to solve this problem using a number line. I'm going to draw my number line. And on my number line, I'm going to start with the total number of children in the park. The total number of children in the park was 16. I am going to jump backwards 7 because that's the number of students that joined. In order to jump backwards 7, I'm going to think about how I could decompose to a 10. I know that if I decompose 7 could be decomposed into 6 and 1, 6 plus 1, right? And I'm going to decompose into 6 plus 1 because that would get me to a 10. So I know 16 minus 6, 16 minus 6 gets me to 10. And then I'm going to subtract 1 more. And that has me landing on the number 9, which is how many students began in the park. So again, we see 16 minus 7 equals 9. I'm able to show that with manipulatives. I'm able to draw a picture, and I'm able to solve using a number line and the decompose to a 10 strategy. For our next instructional strategy, we are going to make the connection between concrete and representational drawings with a comparison problem where no action is taking place. All right, so we have our problem, and I'm going to read it and kind of think through it a little bit before I start doing any math. So Gabe has a toy collection that has 9 dinosaurs and 9 Ninja Turtles. How many more dinosaurs are there than Ninja Turtles? So my math movie in my mind, I can see Gabe, and I see Gabe has some dinosaurs, and he has some Ninja Turtles. And I am trying to figure out how many more dinosaurs than Ninja Turtles Gabe has. So it sounds like I'm going to be comparing the number of dinosaurs to the number of Ninja Turtles and figuring out the difference between them. So the first way I'm going to do that, you guys, is I'm going to build a model using my snap cubes. So using my snap cubes, I see that Gabe has 9 dinosaurs. So I'm going to write the letter D. That way I know that my first model represents my dinosaurs. And I'm going to 1, 2, 3, 4, 5, 6, 7, 8, 9. So those are the number of dinosaurs that Gabe has. The second thing I want to show is I want to show the 4 Ninja Turtles. So I am going to put NT for Ninja Turtles, and I know I need 4. So I can see 1, 2, 3, 4 Ninja Turtles. Well, it's pretty easy to see how many more dinosaurs than Ninja Turtles Gabe has, because I can see that he has more, and I see that these pieces line up. So these are the same, these are the same, these are the same, these are the same. And I can break this piece off right here and see how many more dinosaurs, by our D, dinosaurs he has. He has 1, 2, 3, 4, 5 dinosaurs. And I can use my snap cubes to do that comparison and very quickly see that he has 5 more dinosaurs than Ninja Turtles. But I can also draw a model to help me think about this. So I'm going to draw a bar model, and the same thing I did before, I'm going to make sure I label my bar models. So I'm going to write the letter D, and I'm going to draw a bar model. And I know that 9 represents the number of dinosaurs. So I'm going to put a 9 in this box to represent those dinosaurs. Now, when I get ready to draw my Ninja Turtles, I have 4. So I know my bar for Ninja Turtles needs to be shorter. And you can see how my bar model looks very similar to my snap cubes. So I'm drawing a representation that goes along and matches my concrete model. And the same thinking, I want to figure out that difference. I want to figure out how many more. Well, with my snap cubes, I could break them off and count them. But with this bar model, I can't see the difference. So let me think about an equation I can use to figure out the difference, to figure out how many more dinosaurs the Ninja Turtle scape has. Well, I'm kind of thinking about these two pieces. And I know if I were to figure out 4 plus this amount to give me 9, how many more Ninja Turtles would I need to equal the number of dinosaurs, or how many extra are out here? I could think about that as 4 plus that question mark would equal 9. How many would fill in this space to make those two bars equal? Well, when I see this equation, one way I can think about that is to count on a number line. So on my number line, I am going to draw a number line. My number line is going to start at 4, and I want to make hops until I get to 9. 4 plus how many hops is going to give me 9? So 4, 5, 6, 7, 8, 9. So now I want to see how many hops did I make. So this is 1, 2, 3, 4, 5. That means 4 plus 5 equals 9. So I have 5 more dinosaurs. This is 5 more, because 4, I would need 5 more Ninja Turtles to equal the number of dinosaurs. So this is one strategy that we can use, and that would be counting on. Let's see if there's another strategy. I could also think about this a different way. Again, if I have my bar model, I'm showing 9. Then I have my Ninja Turtles here. 4. And I can think about this a different way. I know I've been doing a lot of work with part wholes in previous problems. And I know that if my whole was 9, and I break off the parts that were the same or subtract the part that's the same, then I would be able to find that piece that's the difference. So if I start with the dinosaurs and I subtract the 4 Ninja Turtles, then I would be able to find that missing number. How many more dinosaurs than Ninja Turtles will I have? Because I would find that missing part. So this time I'm seeing this is subtraction. So what I'm going to do, I'm going to use another strategy, but I'm going to use my number line again. And this time I'm going to start at 9, and I'm going to count back 4 on my number line. So if I start at 9, and this time I'm going to hop back 4. 1, 2, 3, 4. And I want to know what that number would be. So if I take away 1, that would be 8. Take away another one, 7, 6, 5. I land on 5. So that means 9 minus 4 equals 5. So again, that missing piece is 5. And we used the counting back strategy. So what we really want them to see is that you can solve using addition or subtraction. We're recognizing that inverse relationship piece. We're also seeing that the manipulatives that we use connect to what we're drawing. So they're able to see what they're doing with those manipulatives and understand why they're drawing these bar models. Today, we've talked about different strategies. We've also talked about using concrete, representational, and abstract strategies in the previous video. So, which strategy should we emphasize? In mathematics, the emphasis is on reasoning and thinking about quantities within mathematical context. Specific mathematics strategies for teaching and learning are not mandated by the Georgia Department of Education or assessed on state or federally mandated tests. Students may solve problems in different ways and have the flexibility to choose a mathematical strategy that allows them to make sense of and strategically solve problems using efficient methods that are most comfortable and make sense to them. It is critical that teachers and parents remain partners to help each child grow to become a mathematically literate citizen. These standards persevere and affirm local control and flexibility. Thank you for watching our video today.